Hello and welcome to Finch. In this tutorial we're going to dive into the algorithm behind generating a corridor with stairwells and a unit mix. What we have here is a project where I have the imported mass geometry along with grid lines, and I've also drawn a center line. The center lines can be drawn in Finch by navigating here, clicking the drop down button, edit center lines, and then use our 2D drawing tools. Same goes with the grid lines. Drop-down menu, edit grid lines, and then the draw tools. But they can both be imported from your preferred software. The center line can be drawn in Finch or imported from your preferred software. In this video, we're gonna take you through how to get from this to a floor plate where you're ready to start generating your units. If we go and click and navigate to generate, you can see that we have three options regarding the circulation. In this video, we're going to go through unit mix and corridors and unit mix around existing corridor. If we have a center line, which I have, we can go ahead and press unit mix and corridors. And after that, we can generate a unit mix. Let's start with unit mix and corridors. When we get here, we get redirected to this dialog, and you will see that it immediately starts iterating. You have some options to the left, some in the middle, and to the right you can see all your data. If we start in the middle, these black dots are toggled on this button right here and are stairwell attractors. So you can choose what walls you want your stairwells to be directed towards. A use case for this is if you have a nice view here and don't want to ruin these units with stairwells. So I'm gonna go and click these and attract my stairwells to these walls. You can see that it immediately starts reiterating and places these stairwells towards these inner walls. Let's go to the left and work our way downwards. This slider shows how many stairwells we allow the algorithm to generate. So now we have between 1 and 8. If we drag this up to 3, we allow between 3 and 8 stairwells. Then we have our egress distances, which tells us that at any given point, this is the minimum distance to a single stairwell, and this is the minimum distance to two of them, and also their shared path. If we drag this down to so that we just allow 3 and only 3, you can see that most of the points are green, some are gray. And if you look to the right here, you can see in our data drawer that all of these points has maximum of 22.8 meters to one stairwell, and these have approximately 60 meters to two of them. So that's the instant feedback you get from the algorithm. I am going to leave the egress distances as they are for now. And continuing down, we have our weights, which are input parameters that tweak the algorithm and adjust how important each of these inputs are. All of these sliders are going to be essentially trade-offs, so you can't always have the minimum number of stairwells at the same time as minimizing the invalid egress distances. For instance, if we allow between 3 and 8 and have the minimize invalid egress distances set to max, it's going to generate another stairwell to get all of the egress distances max. But if you want fewer stairwells without toggling this one, we can drag this down all the way and put this to the top. And you can see that it will instead generate only 3 of them. And then it found this solution here. For me, it's important that we place our stairwells in the corners. So I'm going to place this all the way up, and hopefully it will generate here instead. It's also important for me that we place stairwells on ends, because I would like one stairwell here. So I will also drag this up. And then you can also toggle this one, which instead will place the stairwells with an even distribution of their length in between them. But I quite like this layout we have here. So the next step is that you can insert your dimensions of the cores. So if you have a core that you usually work with in your projects, I have a core that I want to use, which is going to be 3.6 meter wide and 8.6 meters deep. Okay, I am happy with the layout it has generated for me here. If it's still iterating, you are gonna need to go ahead and pause it, and then you can bake it out by pressing apply plan here. Then we can double check so that the program is set to circulation and that the space type is set to corridor. This is made automatically in Finch, but it's worth double checking if you import it from another software. What this does is that it tells our unit mix that this is points where we can place entrances. Before going forward, I want to refine my course a little bit, so I will turn on my grid lines. And I like this core as it is, I like this as it is, but this one I would like to snap to my grid lines. So I am gonna go ahead and align this to this grid line right here, and this wall to this grid line right here. And this is an important point, that the algorithm runs the numbers for you and it calculates and shows you the data, but you as an architect are always going to be the one in control and making all the decisions. So make sure that you have your circulations and your cores as you want them before moving into the next step, which is going to be the unit mix. So once we are happy with this, I'm going to go ahead and select both of my residential parts. If we go to generate, you can see that we can now use the unit mix around existing corridor as we now have a corridor. This is also the step where you're going to begin if you import your corridor and cores from another software. If we press here, you will see that it immediately starts generate my units based on the unit mix up here. And what I see immediately here is that these units are a bit too small for this building shape. So I will input another unit mix. I want 10% of my units to be 46 square meters. And then I want 45% of my unit to be 70 square meters. And I want 35% of my units to be 93 square meters. And I will add another row with the remaining 10%, which I want to be 116 square meters. What I can also do here is that I can press this expand button and I can define the minimum facade length for each unit size. So this is going to be the aim for the algorithm, and it's going to do its best to hit these values. What I will do now is that I will go immediately to the middle. Here you can see the units represented, and you have this little panel in the middle. Here it gives you some immediate response to the algorithm. To the right, you can see some data as well, but I will start by explaining the numbers in the middle. So the fit is gonna essentially go ahead and look at the units generated and compare them to the sizes you aim for. So if we look at this unit, it's 146 square meters, which is 30 square meters more than my biggest aim unit. Then we have this one, which is 51 square meters, which is 5 square meters larger than this one. Then what this number tells us is the absolute value of all the differences between the generated units and my unit mix inputs. The large number, instead of the absolute value, compares what units are bigger. So this one is plus 30 square meters. Maybe some units are just below these. So it takes all of the bigger units and adds them, and it subtracts the difference from the ones that's smaller than my unit mix. The next number here, the mix, tells me how well we are hitting the unit mix. And you can see here that we have 9% of 46 square meter apartments where we aim for 10%. So we're pretty close, and you can see it's reflected in this data here where we are at 90.5%. The next one is going to be your unique units, where it tells us that we've generated 21 units now and 18 of them are unique. If you want to reuse plans later in the project, it's good to aim at a low number here. Okay, let's go over to the left-hand side again and move our way downwards. These are the unit weights, which are going to be your trade-offs. You're not going to be able to fulfill all of these unit mixes in all of your building shapes. It's simply geometrically impossible. These sliders simply tell the algorithm how important each parameter is. If you're unsure about what each are, you can press this information tab and it tells you that this is the accuracy of requested apartment sizes. For instance, you are not going to be able to hit the exact square meters and the exact unit mix in all building shapes. So for instance, if it's important for us that we have our units as close to these as possible, but maybe the unit mix isn't that as important, you can drag this all the way up and this all the way down, and you let it iterate again. You give it a few seconds Now you can see that we have more apartments that are exactly our requested 46 square meters, but they are too many of them, 33% compared to our 10% that we requested. If we instead slide this all the way down and ask for the algorithm to generate the unit mix as close as possible, you will see that we now hit 9% of 46. We have 48% of 69 or 70 square meters, which is super close to what we defined here. For this project, I'm going to leave these in the middle. But the important part to note about these is that you check what's important for your project, and then you adjust the sliders accordingly, and then you look at all the data it generates, and then you make the decisions as the architect. The next ones are shape-aware and grid lines. In this project, I have imported grid lines, and I will actually start with the shape-aware. The function behind shape-aware analyzes the geometry of the corridor and the building facade. So if we take this all the way up, it will try to find natural lines in the building. So here it continued the corridor. This one looks as if it's 90 degrees from the facade here. Same goes here, 90-degree angle. So it finds the natural lines in the building. If we instead take this down and take the grid lines all the way up, you will see that it hits the walls on my grid lines, which can be a very good way to control where your units are going to be. But you can see that the feedback we get is that we get a bit further away from our mix and we get a little bit more diff. So as I said, these are trade-offs. For this project, I'm going to go with the grid lines. If you look at this area here, you can see that it has a quite small segment of wall. And even if we toggle the shape-aware all the way up, the algorithm simply can't fulfill all requirements at once. And then you need to remember that you can always go in and manually adjust all of your walls after you have baked it out. So we are going to go ahead and toggle shape-aware all the way down. You can adjust the daylight, where the function behind this analyzes the facade area and compares it to the floor area. Squareness, where you can adjust how important it is that the apartments are as close to a square as possible. And then adjacency, which tells the algorithm that we want similar units as close to each other as possible. Continuing down, we can adjust the dimensions of the walls, so we can change the wall width. We are going to leave it at 200 for now. Constraints, we have dual aspect size, which essentially tells the algorithm that any apartment over this size, in this case 100 square meters, needs access to 2 directions. So this unit is above 100 square meters. It has access to north and east. Facade, this is above 100 square meters and it has access to east and south facade. The unit width, which is the internal minimum width of each unit, and how small the area of the entrance can be for each apartment. Respect windows is toggled on as standard. So if we would have any windows in our project, it would respect the windows by not placing a wall going through them. Snap dimensions, which is nice to not get any uneven numbers. So it snaps all of the dimensions to a grid size of, in this case, 100 millimeters. Align walls with core to get a cleaner geometry of the entire floor plate. And extension legs, which I'm going to show here, is this right here is the extension leg, and this function here toggles the minimum length of an extension leg. So if we just set this really high, like 20 meters, it will not generate any extension legs, and this is a solution that I will prefer in this case. This is the minimum angle between walls, and this is the threshold for which a wall needs to exceed to be considered a corner. You can toggle the facade to floor ratio for the units. It's set to 0.15 as a standard. Once you are happy with the layout of the unit mix, you want to go ahead and pause the iterations and bake them out. And here I want to make a reminder that you as an architect are still the one in control. If we look at this apartment, for instance, it's super close to our desired 93 square meters, but I still would prefer that these 2 units align to this wall flush. So I will go and align it with our align tool, which will put this up to 99.1 square meters, which I would actually prefer to have this clean geometry of my floor plate. And that's the final reminder that you as an architect still can refine the results. The algorithm is constructed to help you, to give you the relevant data for your project, but not to make the decisions for you. So generate until you're happy with the result, and don't be afraid to refine until you are happy with the result. And that brings me to the end of this video, because I am happy with this result, and these units are now ready for me to generate my units in them. That is it for this video. Thank you so much for watching. Bye bye.